Hey guys, so welcome to the code injection class again. This is gonna be a second technique where we are gonna be able to understand when the malware is doing code injection, and also we are gonna learn how we can intercept the code injection in memory so that we can understand exactly at the point of infection what the malware is about to do. In this technique, if you remember the previous one about create remote threat, the malware was scanning the processes in memory running and then choose one specific process and infect it. In this case, the malware is gonna run a program from disk. It's gonna use a legitimate Windows program. Once it's loaded in memory, it will load it in suspended mode, which means load it in memory but don't execute. After that, it's gonna infect that specific process and then resume execution, and therefore that legitimate Windows program is gonna be infected, which is gonna be hard to find by the end user, by the victim, because it's gonna look like a legitimate process, but behind the scenes it's gonna be doing malicious actions. Okay, so we're gonna learn exactly how that is injected and how we as a malware analyst can deal with those kind of injection or infection techniques. So as usual, I open the binary in IDA, and it's kind of big, so it took some time to load, so I do it in advanced. Okay, and then at the same time I'm gonna drop the binary into Immunity Debugger. Okay, so we are ready to go. We have the debugger ready, and we have the disassembler ready to analyze. So as again, we are not gonna be doing full analysis. We are just dealing with code injection, so don't worry about all those different instructions. So we go to IDA, and as usual we go to imports. From imports, we have here write process memory selected, but as again, if you just wanna find it quickly, you can start typing the word, write process, and eventually while typing it, IDA is gonna go to that specific location if found. In this case, since it is not packed, it is not obfuscated, we can right away see that write process memory is being used, which means that API is gonna help to write code into a process, which gives us a really good clue about code injection. We double click on it, we press X. Once it is highlighted, we can see that it is being used 3 times. We click on the first one and then click OK, and then we get to the meat. Okay, so here's the write process memory. We can see set thread context, resume thread. So let me explain you this whole flow. Okay, so normally it's going to start with a create process at the beginning, as you can see here. There are other actions before, we don't care about them. Now as usual, we can label this function as injection code. We can have it always in our IDA analysis, and then we can go to create process. Here is gonna load a legitimate Windows program in suspended mode. Once it is loaded, it's gonna get the thread context. Keep in mind, guys, that when a program runs in Windows, we always talk about the processes running, right? But behind the scenes, actually, it is a thread that is being executed, and after the thread, it will be a process. In other words, actually, it is a thread who runs programs in Windows, right? And the process is just an attribute within the thread. So in this case, once the process is running, the malware is gonna get the thread context, which means all the environment related information from the thread, like registers, like stack information. And the reason it's gonna get that is because once it gets the context, it will go and read the process memory of that specific program that was just loaded. And from there, normally, like in this case, it's gonna say, okay, I loaded this program in memory, suspended, I get the context, and now let me read the base address of that specific process. Once I read the base address where it is being loaded in memory, if that base address is similar to something that I'm comparing here, we will see that in a second, don't worry, then goes to this branch, which means empty on map view of section. That empty on map view of section API is gonna remove the whole binary from memory. Normally this is called process hollowing, as you remember, which is gonna remove the whole binary from memory, and then via virtual alloc is gonna allocate a new chunk in the same space, but with malicious code that is gonna be written later via write process memory. Okay, now if this base address is different that we are reading here, goes to this write branch and basically saying, okay, so since the base address is not the same that I'm trying to match, I'm just gonna go ahead and instead of replacing that specific chunk in memory of the process to be infected, I'm just gonna allocate my specific base address. Okay, so just to recap, either it will unmap the whole binary from memory and then allocate in that unallocated chunk a new memory space, or it will just allocate directly without unmapping. We will see the difference in a second. But at the end of the day, we allocated some memory in the remote process via virtual alloc X. Once that memory is allocated, eventually we can see here some calls which we don't care about in this specific exercise. Those are gonna decrypt a specific binary in memory, and then it will call write process memory to inject that specific code into the process so that the infection is consumed. And finally, once everything is ready to go, it will call SetThreadContext to put basically parameters like the instruction pointer, which is the first instruction, or or also called entry point, which is going to be the first instruction to be executed into that process infected. And the last step is resume thread. I open the process, I replace it with malicious code, I put all the parameters in the thread, which is the main entry point, and now resume thread is going to start executing that process with the malicious actions in place. So as usual, let's see how this whole thing works. Okay, so the first thing is we are gonna go to create process in the debugger, and we are gonna put a breakpoint. Now you can put a breakpoint in the create process A, in the debugger, as you remember, just by going to the command line of the immunity debugger and put BP space create process A. But that scenario is gonna break the debugger inside the create process A function, and I don't wanna break inside it. I just wanna break before being called, because I'm not interested to break into it, to step into that function. In other words, what I'm just gonna do is I'm just gonna grab this specific address, which is gonna be the one before executing create process, and I'm not gonna step into it, just gonna break there to go over it. Okay, so I grab that address, then go here in the debugger, click Ctrl G, then we put here our address. Okay, and we are right there. As I said, we are ready. If I click enter here, it's gonna take us to create process, And here is the starting of the function. If we put, as I said, the breakpoint on create process A, the debugger is going to step right here, and I don't want to step inside. I want to step outside of it, which is right here. Okay, so I put an F2 there, F2 for the breakpoint, and then click on play. It runs, and then you can see here in the parameters in the stack, in the lower right, the module file name. We can see right away that the module to be loaded is Internet Explorer. And this is the interesting thing, guys. The way it's going to be created is suspended. In other words, it's going to be loaded in memory but not executed yet. Okay, so let's fire up Proc Explorer so we can also follow this specific creation. We have here our debugger, we have here our malware, and we might see under the malware Internet Explorer as soon as we execute this function. So let's click on F8, and you can see that it is kind of starting something. We can see here that Internet Explorer was created, but see that it is in suspended mode. Okay, it says it's Microsoft Corporation, Internet Explorer, and even you can see the path. Okay, legitimate file. Okay, after that, guys, it's gonna check with test EAX to see if there is any error. There is no error. And then after that, there is a load in EAX and specific buffer, and then a function. Again, it's kind of hard to follow there, so let's go to IDA. In IDA, we can see that after the create process, if it is 0, it's not the case. So we go to this brand. It loads this like an address in EAX, and then we don't know what it is, but if we double click on it, we can see that EAX is going to be passed to EBX, and then it will call virtual unlock, which is going to allocate a buffer. That buffer is stored in EAX and save back to EBX. In other words, it's going to allocate a buffer, and that buffer is going to be stored wherever EBX is pointing to, but EBX, as you see here, was set by EAX, and therefore we know that we are just allocating a buffer. Just quickly rename this alloc, whatever you want to call it, and then EAX is basically just the pointer passed before calling this function, and it's just saving move it to EBX, and the result of the buffer being created is going to be stored there. So if we go back, you can see that EAX is exactly pointing to that buffer, and then that means that after this be unlocked, EAX is going to have a buffer that is called context, and IDA is putting this label automatically because we're going to call get thread context later, and that thread context is going to save exactly in that buffer the context of the thread that is that we just started via create process. Okay, so we create the process, we create a buffer to save the context, and then we're gonna call get thread context to get the context of the thread that is just about to be executed, in this case Internet Explorer. So let's do that in the debugger. I'm just gonna step over this function and check EAX value. We can see that it allocated this buffer. That buffer is saved into that specific EBP-10, which we know it is the context. And then if we click F8, we can get to the get thread context call, and we can see that the thread, which is in this case related to Internet Explorer, is the handler being passed to the get thread context, and then the context buffer, which is going to receive all the context from that specific thread, is ready to hold that information. We right click, put following dump, and we are here waiting for that information. If we click on F8, you can see that it filled out some information. Then It checks if it is an error. 0 is not the case. And now that we got the thread context, the next step, guys, is read process memory. Okay, and it's gonna read information from the remote process, in this case Internet Explorer, and it's gonna read the base address. And how do we know it's gonna read the base address, guys? Okay, so the reason we know that is because if you check in IDA, okay, we can see in IDA that here is the base address. In read process memory, the second parameter is the address to read from the remote process. In this case, it's base address. And IDA knows that because you can see here that EAX receives the context structure. Okay? The context structure plus 84 is gonna give us the PEB, which is the process environment block of that process, and that process environment block plus 8 is gonna give us the base address of that process. That base address is finally pushed into read process memory as second parameter. In other words, this is the way it calculates the base address of the remote process. Okay, and it's gonna read it. Okay, in other words, sorry to reiterate, guys, so that you understand, it's gonna say go to that process, grab the PEB plus 8, which is the base address, and give it to me. Okay, and we're gonna see why it will do that. So we go, click in read process. We can see here that 17C is the process ID handler, sorry, the process handler of Internet Explorer. The base address, now it knows that that specific process, the base address is located at this offset. And let me okay, and then this buffer is gonna read that address and copy it into our process. We are, as usual, we click on following dump to see what is gonna be copied, and it is just 4 bytes, which is an address that we're gonna read. Okay, so at this point, let me open this excellent tool, Process Hacker, that is also helping us to analyze the process. So we have here process Internet Explorer suspended. We click on properties, we click on memory, and if you see here, guys, okay, it can give us all the information from that process. And you can see here that PEB, guys, okay, PEB is located at 7F FD F000. Okay, and if you check here, guys, it says base address 7F FD F008. You see the difference is just 8 bytes, and as you remember, that was exactly what we described here. PEB plus 8 is gonna give us the base address of the remote process. Okay, so watch closely the buffer. We click on F8 and we can see that it's gonna return 0101 little endian, which means 1010000. That's the base address of the remote process.